for the content that we're sharing so that others can benefit from it. All right, so we are looking at graphing linear equations. And a linear equation is the equation for a straight line. Now, there are different formats in which linear equations can appear. As you see here, you can have y equals 2x plus 1 as an example, 5x equals 6 plus 3y, or y upon 2 equals 3 minus x. Let's look at example 1. In example 1, the graph is a straight line, and we can see that when x increases, y increases twice as fast. For example, where x equals where x equals 1, y equals 3. Right? Can we see that? See that there? I'm breaking up. Is anybody able to hear me clearly?
Hearing you now, miss. What was the question?
All right. So we're looking at this equation, right? And based on the graph, we can see that when x increases, y increases twice as fast. So we need 2 times x. And when x is 0, y is already 1. So x is 0 here, but y is already 1. So what this means is, for every value of x, we're going to multiply it by 2 and add 1 to it, which is the equation here. So let's look at it again. When x is 0, y is 1, right? But when x is 1, y is 3. Can we see that from graph? If you follow the arrow, you will see what I'm saying.
Yes, miss. Seeing that.
Right. So from this, we can say that y is equal to 2 times x, because 2 times x here would be 1 plus 1, right? And that is how the equation comes about. All right? Now, when we are given an equation, we can actually determine the values of y by substituting values of x, because here we see that y is already the subject. So we can easily, most of the questions will give you the range for which you should calculate the values of y. And you will understand when you see the CSEC sample questions, but this is just some background information. So let's say, for example, if we wanted to use values of x be -1, 0, 1, 2, when we substitute the values of x into y equals 2x plus 1, when x equals -1, where we see x will put -1, so we'll end up with 2 times -1 plus 1, and that will equal to -1. So we're saying when x equals -1, y also equals -1. Where x equals 0, we'll get y to equal to 1, and so forth. Everybody's following so far?
Yes, miss.
All right. Now, there are different forms in which linear equations can appear. And here are some examples of the forms that a linear equation can take.
Miss, you're breaking up.
Oh, Lord. I'm following what you're seeing on the screen.
Miss, repeat, please.
Oh, yeah. This my internet connection is unstable. Just a second. I'm going to see if I can.
Yes.
Just a second, guys. Are you able to hear me better now? Yes.
Repeat, miss.
Are you able to hear me better now?
Yes, miss.
Okay. All right, so I'm continuing. I wanted to set it up so that you guys don't have to wait. So continuing, I was saying that there are different ways of writing linear equations, but they usually have constants as 2 or c and must have multiple variables, meaning x or y, right? So here we have, this is kind of like a general form, y equals 3x minus 6. But then there is also the form y minus 2 equals 3 times x plus 1. We must, however, be careful to note that these are not examples of linear equations. The equations with exponents, square roots, and cube roots, etc., are not linear equations. I remember linear equations are just equations of a line. So it's not saying that they're not, it can be graphed. However, they are not linear, meaning when you plot the values of the equation, you will get a straight line. Now, there is the slope-intercept form, which is the semantic form, y equals mx plus b or y equals mx plus c, right? We know m is the slope or gradient, and y is the intercept, which meaning where
You're still breaking up. I can hardly hear you.
Oh Lord, is that happening for everybody?
Miss, I'm not hearing you.
Oh, guys, I don't know what the matter is. I switched from Wi-Fi to Ethernet, so still here.
May I hear Miss? What in now?
Let us see if we can explore the straight line graph. So we can see the effect of different values of m and b. All right, so we're gonna be moving the m and b pointers, sliders, to see what happens when we do. So this is m, and we know m represents what again? M represents what, guys? All right, so we're at, guys, can you hear me?
Yes, Miss.
Okay, so we know m represents the gradient of the graph, right? As a, so this is the positive gradient, right? This is the negative gradient.
Positive, you move to your right. Negative, you move to your left.
Right, negative is skewed to the right, and the positive is skewed to the right. That is one difference. Now, if I have my gradient to be 2, positive 2, and my b to be positive 2, you see, all right, so that's where my b is positive 2, right? I'm going to change my b to positive 3 now. What do you realize happening? What do you realize happening? Remember, B represents what again?
Positive 2.
Yeah, but what does the B represent? B represents the what intercept? B represents the y-intercept, meaning where the line cuts the y-axis. So if you notice, the higher the B value or the C value goes, the higher up on the y-axis the line will be. You see what's happening there? You see?
Yes, miss.
Right. So remember that the B value is just where the line cuts the y-axis. All right. Oh, Lord. So we're going back to the main now. I hope everybody's following so far. All right, so we just looked at the intercept form, right? The slope intercept form. Now we're looking at the point slope form. The point slope form of writing a linear equation is a representation, is y minus y1 equals m times x minus x1, right? Where y1 equals 3, it is here in the example. The gradient m is a quarter and x1 is 2. This form is not used quite often, but it is one format of writing the equation. Here is the general format now, which is ax plus by plus c equals 0. In the equation, a is the coefficient of x, b is the coefficient of y, and c is the constant, as we are aware. Still following? Still following?
Yes, miss.
All right. Sometimes a linear equation is written as a function with f of x instead of y. So just bear in mind that f of x is the same thing as saying y. And functions, sometimes we have h of g, h of u, h of f. You can identify functions quite easily, and we will learn a little bit. So what I want us to learn how to graph the new thing that we will learn. So now the first thing we want to do is we want to where I'm gonna add it to the question. Okay, the computer is not responding. Just a second, please. All right, so it's gonna be where x is less than, can I find it? No, I'm gonna have to write it. Wrong, please. Equal to 3, but is greater than or equal to 5, negative 8. This in equation? Yes, no. So the question is asking us, graph the line y equals 5x plus 2, where x is less than or equal to negative 3, but greater than or equal to 5. Everybody's following there?
Yes, miss.
All right. So in doing this now, we're gonna have to have values of x. We're gonna have to tell what 5x is.
Miss, question.
Yes.
But the two signs are the same, right? Then
Here, remember it's one sign, but it depends on how you read it. So when you see an equation looking like this, you start reading from the middle, the variable. So the variable here is x, and you read to the left. So if you notice the point is turned to x, that means x is less than or equal to,
okay.
right? So x is less than or equal to negative 3, but greater than or equal to positive 5. You seeing that?
Yes, miss.
Okay, very good. All right, so this is our table. I'm gonna do it freehand, guys, to conserve on time. So please bear with me on that one. So we're gonna put values of x. Since it's less than or equal to is -3, -2, -1, 0, 1, 2, 3, 4, 5, right? And you close your table. I would have used my ruler, guys, but just to conserve on time, we're already shortchanged because of the difficulty I had this morning. It looks awful though. All right.
Yes, miss.
So
And I
we're
want to
yes,
hurry
go
on
ahead.
because I have mock exam tomorrow.
We have mock exam tomorrow. All right, I understand. After we do this, we're just gonna go straight into plotting the graph. And then I'll just give you some questions to practice. All right.
Okay.
All right. So we are gonna take the values of x. For this line, we're gonna take the values of x and multiply them by 5. So all we did, we just brought down the parts of the equation. So we don't know what x is. This is what tells us what x is. So we put the value of x there based on the inequation given. Then we take the part of the equation that is multiplied by x, put it into one row. Then we take the constant, which is 2. It's always just going to be 2 plus 2. So you can just fill that in easily. And this is just to show the progression as to how you get the values of the equation. So if you're able to like bypass a few steps in time to come, nothing is wrong with that. So we're taking 5 now, multiplying it by -3 because we're replacing the values of x in 5x. So 5 times -3 will give us
-15.
negative. 5 times -2 will give us
-10.
-10. 5 times -1 will give us
-1.
negative
-5. Sorry.
5. Very good. 5 times 0 will give us
0.
0. 5 times 1.
5.
5 times 2.
10.
5 times 3.
15.
5 times
15.
20.
and 5 times
What?
5.
25.
All
I
right.
still can't believe
So now we're adding 2 to each of these. So
that.
-15 plus 2 gives us
13. -13.
-13. -10 plus 2 gives us
-8.
-5 plus 2 gives us
-3.
0 plus 2 gives us
2.
0 plus 2,
2.
2.
2.
Yes, 0
Right?
plus 2 is 2, literally. 5 plus 2,
10.
5 plus
7.
2.
7. 7. I'm sorry.
That's okay.
7.
It's okay. 10 plus 2,
12.
15 plus 2,
17.
20 plus 2,
22.
25 plus 2.
27.
Right. So what we're saying from this table now is when x equals -3, y equals
-13.
right. When x equals -2, y equals.
-8.
When x equals -1, y equals.
-3.
And so on. So this is how we now get the ordered pairs to plot the points on our graph. Right? That sound familiar? Ordered pairs and plotting points. Does that sound familiar?
Yes, miss.
All right. So what I'm going to do now is I'm going to drop my Cartesian plane. So we're going to draw up our Cartesian plane, guys. I'm not sure if you guys have graph paper, but there is a GeoGebra link that you can use, but it might be a little bit challenging to manipulate it using your phone or tablet. It's not impossible, but it might be challenging. All right. So I can share that link with you so that you can make your graphs. But I'm gonna be using my whiteboard here. So let me zoom out. All right, so we should be familiar with drawing a Cartesian plane by now, but I'm just going to run you walk through the steps really quickly. So when I'm using my graph paper,
Miss,
I
the
like
meeting is
to
going to
estimate
end.
to the middle of it. Oh,